What's up, everyone? Welcome back. Patrick here. Moving on to a couple of more problems dealing with linear systems. So we got to find the measure of each angle in each triangle below. So this is like 3 questions here, and they're all dealing with triangles. So question number 1, the measure of the middle angle in a right triangle is 30 more than 3 times the smallest angle. Scenario 2, we have each of the equivalent angles in an isosceles triangle are 6 less than half the remaining angle. And then number 3, the largest angle in a scalene triangle is 40 less than 3 times the smallest angle. Then the smallest angle is 10 more than half the middle angle. So a bunch of different scenarios. Wanted to kind of expose you to different types of questions that you can get and get some practice in adapting to whatever information you're given. So the first one, the measure of the middle angle in a right triangle is 30 more than 3 times the smallest angle. So a right triangle, we know that one of the angles is 90 degrees. And so if we call this angle here x, we can call this angle here y. So notice that both of these, if this is 90 degrees here, we know that the total angles in a triangle add up to 180. That means that these 2 angles, when you add them up, have to equal 90, because we got 90 over here, and then these 2 have to equal 90. So 90 plus 90 would give us 180. So one of the equations we can make is x plus y is equal to 90 degrees, these 2 here. And let's say that we let x be the smallest of these 2, and then y would be the middle. Notice that 90 is always going to be the largest angle in a right triangle because these 2 have to add up to 90, right? So x would be the smallest, y would be the middle, and then the 90 degrees is the largest angle. So what they say is the measure of the middle angle, which is y, in a right triangle is 30 more than 3 times the smallest angle. So if we take the smallest angle, multiply it by 3, and then add 30, we would get that middle angle y. And so now notice, with all that information, we have 2 equations and 2 unknowns. So we could just solve for x or y using substitution or elimination. I'm going to use substitution because the y is already isolated here. So I'm going to take this, plug it into that y. So we'd have x plus this expression, 3x plus 30. Plugged it in for y here, and that's going to equal 90. And then bring the 30 over, x plus 3x, that would give us 4x. Then we'd have 60 on the right side, 90 minus 30. Divide both sides by 4, x would be 15. And so if x is 15, then it's easy to figure out y. It would just be 90 minus x, because x plus y has to equal 90, so that would give us 75. And then you could test it. Notice that both of them added together does indeed give you 90. And notice if we take this, multiply it by 3, we would get 45, add 30, 45 plus 30 does indeed give us 75. So we could be pretty confident that those are the 2 solutions. Moving on to the second scenario. So each of the equivalent angles in an isosceles triangle are 6 less than half of the remaining angle. So let's draw a diagram here. Now, an isosceles triangle, we know that 2 of the angles and then 2 of the sides have to equal. So this angle and this angle are equal. Let's call it x. And then this angle here is y. That's the remaining angle here. So notice that just from this, we can create an equation. We know x plus y has to equal what? 180. So we can say 2x plus y is equal to 180. That's the first equation. The second equation, let's read this sentence carefully. So each of the equivalent angles, which are these, in an isosceles triangle are 6 less than half of the remaining angle. The y is the remaining angle. So if we take the y divided by 2, which would be half of the remaining angle, and then we subtract 6 from that, we would get one of the equivalent angles. right? So each of the equivalent angles, x, in an isosceles triangle are 6 less than half of the remaining angle. Right? So hopefully you could see from that wording how we got this equation here. And now we got two equations, two unknowns, so we can just solve for x and y. What I'm going to do is, x is actually already isolated, so I'll plug in this for this x value. So we'll have 2 times y over 2 minus 6 plus y is equal to 180. Right? I just took this, plugged it in here for that x value. And so now we can distribute the 2 inside the bracket. 2 times y over 2, notice the 2's would cancel out. We would just be left with a y there. 2 times negative 6 is negative 12, plus y equals 180, like that. Bring the negative 12 over, 180 plus 12 would give us 192. Y plus y would give us 2y. And then we can divide both sides by 2 to get the y by itself, and that would give us 96, like that. So we have this angle here, the y, and then to find the x, we can just plug it into either or. Let's plug it into this one. So we'll have 2x plus 96 equals 180, like that. So then 2x would equal, what, 84? Right, when we bring the 96 over, 180 minus 96 is 84. Divide both sides by 2, x would be 42. Then you could check it. So we could take 42 plus 42, that would give us 84. And then 84 plus 96 would indeed give us 180. And then if we check this, if we check the sentence, if we take the remaining angle divided by 2, 96 divided by 2 is 48. And then subtract 6 from that, 48 minus 6 gives us 42. So everything checks out, so those are the two solutions. And then finally, the third scenario. This one's going to be the most tricky out of all of them. So in a scaling triangle, the largest angle is 40 less than 3 times the smallest angle. The smallest angle is 10 more than half the middle angle. And the reason why this one's going to be the trickiest is because it's a scalene triangle, so all of the angles are going to be different. So notice here, we're going to have 3 variables. So if we have 3 variables, 3 unknowns, we're going to need 3 equations as well. Now, one of the equations we can make is x plus y plus z is equal to 180, right? All of the angles summed up have to equal 180. And let's say that this is the order of the size of the angle. So the x is the smallest angle, the y is the middle angle, and then z is the largest angle. And notice that they say the largest angle, so z, is 40 less than 3 times the smallest angle. So if we take the smallest angle, x, multiply it by 3, subtract 40 from that, that would give us the largest angle, like that, right? The largest angle is 40 less than 3 times the smallest angle. And then the smallest angle is 10 more than half the middle angle. So if we take the middle angle, which is y, divided by 2, half of that, and then add 10, we would end up with the smallest angle, like that. Right? The smallest angle is 10 more than half the middle angle. And now notice we got 3 unknowns and we have 3 equations. So that's what makes this tricky, that there's going to be multiple steps here. There's multiple ways you could solve this as well. What I'm going to do is notice that the z here, it's in terms of the x. So we could take this, we could plug it in for that z, but then we're going to have x, y, and then an expression in terms of x. So we're still going to have 2 variables there. We won't be able to solve in that equation. But what we could do is we could take this equation and take the y, isolate and make it in terms of x, and then plug it in for that y. So then we're going to take an expression for y, all in terms of x, plug it in here. Take an expression for z, all in terms of x, plug it in here, and then that equation will be all in terms of x. So this y over 2 plus 10, I'll do it on the side here. How can we isolate for this y? Well, the first thing I would do is I would actually multiply everything by 2 to get rid of this denominator here. So y plus 20 is equal to 2x. All right, so this expression and this expression, they're the exact same thing. They're just in a different format. I just took everything, multiplied it by 2 to get the y by itself, and now the y equals 2x minus 20. And so we could take this expression, plug it in for y, take this expression, plug it in for z. So if I do that on the side here, we'll have x plus the y, 2x minus 20, plus the z, which is 3x minus 40, and that equals 180, like that. And now notice we have an equation all in terms of one variable, x. So what I'm going to do, I'm going to add all the x's. That would give us 6x. And then we'll have 180, negative 20 minus 40, that's minus 60. When we bring it over, that would be plus 60, like that. So we'll have 6x equals 240. So x would be 40, like that, when we divide both sides by 6. So now that we have this x value, which is the smallest angle, we could find the other ones. Actually, we could find them both with these expressions. So notice that the y is equal to 2 times 40 minus 20, which would give us 60. So that would be the middle angle. And then notice we can find the z pretty easily. We could either add these two, which would be 100, and then all the angles have to add up to 180, so we know z would have to be 80 for all of them to add up to 180. Or we could have took this x, plugged it in here. 3 times 40, which is 120, minus 40 does indeed give us 80. Right, so those are the 3 angles for this triangle here, and then you could test it. All of them sum up to 180. The largest angle is 40 less than 3 times the smallest angle. So the smallest angle multiplied by 3 is 120, subtract 40 gives us the largest angle, which is 80. Then the smallest angle is 10 more than half the middle angle. So if we take the middle angle, divided by 2, which is 30, add 10, we would end up with 40. So everything checks out, and those are the 3 solutions.